would like to share about titration in the food industry. So, what is titration in the food industry? Titration in the food industry is to determine the concentration of a particular substance within a food product. This method involves adding a solution of non-concentration, the titrant, to a solution of the substance being analyzed until a reaction is completed, often indicated by a color change. By doing titration in food, can analyze purity, quality, and the content of the food.
I will talk about theory of titration. First is definition of titration. Titration is a method of chemical analysis that determines the concentration of an unknown solution by reacting it with a known solution of another substance. Second is the type of titration. There are different types of titration including acid-base titration, redox titration, precipitate titration, and complex volumetric titration. Third is titration technique. When the acid and base react at an equivalence point, a second chemical is added using a titration procedure. This chemical change color and always present in large concentration by analyte, which is determined by the formula N equals to mv and might exist at a lower level. Next is the purpose of titration. Titration are used to compute and determine unknown concentration using a known titrant. An indicator is called acid-base indicator, and if its solution change in color in response to change in. Lastly is acidity determination. Acidity determination in titration is a method of measuring the amount of acid in a solution by adding the base until the reaction is complete. The base is usually a solution of sodium hydroxide with a known concentration. The point at which the reaction is complete is called the equivalence point, and it can be detected by using an indicator, a device, or a color change.
Then, this is introduction to the application titration of citric acid in fruit juice. The experiment will titrate a measured volume of citric acid with a solution of sodium hydroxide of a known concentration. The acid and the base react with one another according to the equation below. Each one molecule of citric acid contributes 3 ions of H+ to the reaction. For example, acid-base titration. Equivalence point is defined as that point where the amount of base or H- have been added off there where the amount of acid H+ initially present in the solution being titrated. The objective of this experiment is to determine the concentration of citric acid in fruit juice using titration technique.
Next, I want to talk about the material. First, sodium hydroxide solution, dilute lemon juice, phenolphthalein indicator, burette, redox stand, burette clamp, pipette, bull pipette, beaker, conical flask, water, and funnel. Next, I want to talk about the methodology. First, the burette was rinsed, 10 ml of sodium hydroxide was added to the dry burette, and the solution ran through the burette tip to a waste beaker. This process was completed a total of 3 times. The burette redox stand and clamp were set up. The burette was filled using a funnel so that the minuscule of the sodium hydroxide solution was above the 0 ml mark. Let some of the solution run rapidly from the burette to expel all air bubble from the tip and bring it below the 0 ml mark. Using a pipette, transfer 20 ml of the dilute lemon juice into a clean conical flask. 6 drops of phenolphthalein indicator were added. The dilute lemon juice in the conical flask was titrated slowly with the sodium hydroxide from the burette while shaking the flask until the indicator color changed. The color change and reading at the endpoint of the titration were recorded. 2 until 3 times were repeated and all the readings were recorded in the table.
Result, concentration of NaO obtained from materials reached 0.1 molarity. Our starting point for the first titration portion was 0 and it ended at 17.4 milliliters. Then we start the second titration by topping off to 0 once again, and similarly for the third titration. To determine how many milliliters of NaO were titrated, we use the equation final volume minus initial volume. For example, 17.4 milliliters minus 0 milliliters equal to 17.4 milliliters. Each titrated volume needs to be divided by 1000 or 10 power of negative 3 to convert it to liter. Next, moles of NaO must be determined in order to determine the moles of citric acid. By using the information we have, which is the concentration of NaO 0.1 molar and the volume of each titration of NaO that has been determined. For example, in this slide, it is given 0.1 molar multiplied by the value of volume of NaO, which is the first titration 0.0174 liter equal to 0.00174. And then, we include the equation of citric acid and NaO to see the moles comparison. Based on equation stated, we could see there's 3 moles of NaO and 1 moles on citric acid. Then 3 moles of NaO are multiplied by the value of 0.00174 from previously to obtain the final value of citric acid, which is 0.00522. We'll move on to the last part of results. Concentration diluted multiplied with volume diluted equal to concentration original multiplied with volume original. The formula is the same as MAVA equal to MBVV. Then we rearrange the formula to make the concentration diluted is the subject. We were using the information given where concentration original is 2.61 mole over liter and we're using 1 liter as original volume. Then 10 liter, it represents the total volume after dilution, which includes 1 part of the original solution and 9 part of the solvent. Then we just substitute the value into the formula. Took 6.1 mole over liter multiply with 1 liter and divide by 10 liter. 2.61 mole over liter multiply with 1 will get the same value. So we are left with 26.1 mole over liter divided by 10 liter, and the final answer is 0.261
In conclusion,
mole over liter.
titration is an analytical technique used to determine a substance concentration by reacting with another substance solution. The process of titration determines citric acid level in lemon juice demonstrated its practicality and significance in ensuring product quality and consistency. Through the use of titration, we can precisely measure the amount of citric acid present, an essential factor for meeting both customer expectations and following regulations. This analytical method helps with maintaining the desired taste profile and also assists in making information decision in product formulation and quality control process. Therefore, titration is considered a crucial instrument in the food and beverage sector, playing a key role in maintaining product quality and staying competitive in the market.